Hello everybody, this is Dr. Christopher White, and in this video we're going to be looking at assignment number 1. Now assignment number 1 is a web-based assignment, and don't panic, it's a nice easy one just to get you started. Okay, if you want to know the web address for this website, you can look in the information box below this video, or you can find a link directly to it in the class D2L page in the content section. Alright, so what have we got? Well, the website itself is going to ask you to identify 12 randomly selected rocks using a set of criteria that the website provides for you. The goal of this exercise is just to get you thinking a little bit about identifying rocks and the kind of features that geologists look for. Now this is to get you set up for the next assignment, which is where we're actually going to look at a presentation in which I have some pictures of several different types of rock, and you are going to try and work out what those rocks are. So what are we going to do? So, alright, well there's a description here at the top which I would strongly recommend you read. Alright, now underneath that we have this table, and this table essentially covers the list of criteria that you are going to use to identify your rocks. So there's 4 criteria: texture, grain size, composition, and rock name. That's what you're going to be looking for. Now in terms of the texture, that one's a relatively easy one. Clastic rocks tend to have quite a grainy texture to them because they're made up of pieces of other rocks and minerals. Chemical rocks, on the other hand, tend to have quite a fine grain texture because the minerals have been precipitated from some medium, normally water, and so this means the crystals that form will very often be quite fine grained. Finally, at the bottom here we have biologic rock, should I say. Biologic rocks will very often be made from either bits of shell or from bits of plant material. So the most common biologic rocks are fossiliferous limestones or coal. So they should be pretty easy to spot. Okay, so you'll notice, by the way, that for chemical and biologic rocks, in terms of grain size, there's none, because the crystals that we get in those rocks are normally very, very fine, so we're not really concerned about that. In contrast, for the clastic rocks here, you can see there are a range of grain sizes. And if you remember, our grain sizes go smallest to largest: clay, silt, sand, gravel, cobble, boulder. So if you look here, we have a range of different sizes here. So essentially we have a clay size at the bottom, 1/256. We have a silt size, 1/16 or less than 1/16. We have a very fine sand size, greater than 1/16. We have a sand range, 1/16 to 2 millimeters. We have essentially the kind of sand range, that would give you a gravel, greater than 2 millimeters. So if you look over here, there are slight differences. So for instance, if it's greater than 2 millimeters, you have 2 options: rounded or angular. So please bear that in mind. So anyway, you're going to do the texture, you're going to do the grain size, you're going to do the composition. Now remember, if it looks kind of light in color and it's clastic, chances are it's dominated by quartz. If it looks more pinkish in color, chances are it's dominated by potassium feldspar. If it looks rusty in color, well, that's the cement. Okay, that's not actually a mineral that's important. That's all that's it's the cement that's holding the rock together. So just bear that in mind. Now once you think you've gotten the right set of minerals, you are then going to go across and name the rock. So if I was to select feldspar quartz, I would simply go across to Arkose. If I select quartz feldspar, I would go across to sandstone. So once you've selected your minerals, your composition on one line, you're simply going to continue across to the rock name. You're not going to go quartz feldspar and then jump up to conglomerate. In terms of chemical rocks, well, you can see chemical rocks are dominated by not dominated, it contains a few options. We have quartz-based rocks, or silica-based rocks. We have dolomite, calcite, and then we have the evaporites, halite and gypsum. Now, in terms of all of these rocks, they're going to be fine-grained, so you can't see crystals. In terms of the silica-dominated rocks, typically they'll look quite, well, I tell a lie, but they'll typically look grey in colour. And they'll typically have conchoidal fracture, so they'll have a fracture on them that looks kind of like a semicircle, almost like a scallop kind of shape, like a scallop shell. They will also, of course, not react with acid because they're made of silica. Now, dolomite and calcite are both carbonates, so they will both react with acid. However, calcite will react with room temperature hydrochloric acid. Dolomite will not react with room temperature hydrochloric acid. If you want to make dolomite react with acid, the acid has to be hot. So just bear that in mind. Halite and gypsum, they won't react with acid. Both of them are relatively soft minerals, so they'll scratch relatively easily. In terms of the biologic rocks, well, keep an eye out for pieces of shell. That's going to be one key indicator. And obviously keep an eye out for pieces of vegetation. That's going to be an indicator you might be dealing with something like a coal. Alright, so in terms of our samples, let's go for sample number 1. Okay, here we go. So here's sample number 1. We can see we have this greyish brown rock. Straight away I can see that it's rather fine grained. We can't really see any crystals, so let's go up for the close-up view. If you look just below the image here, there's a bit of text that says click here for close-up image, and here's the close-up image, and you can see very, very clearly there are no obvious crystals, so chances are this is not a clastic rock. But let's continue. Let's try and get some extra pieces of evidence to back up that supposition. Okay, here we go. Hydrochloric acid test. What happens if we put some acid on our sample? Right, box pops up at the top here. The sample did react to hydrochloric acid. Well, that means it's a carbonate. So we have two carbonate options, dolomite and calcite. Well, we just discussed this a second ago. Calcite will react with room temperature acid, dolomite will not. The acid test that they use for this particular website is room temperature acid. So that means chances are this rock is made up of calcite. Oh, someone driving past my house in a rather noisy car. There you go. So next is the hardness test. So you can see we have hardness test 1 to 10. That's obviously the Mohs scale. Talc being 1, of course, and diamond being 10. So let's just hit the numbers. So hardness of 1, the sample was not scratched. Hardness of 2, the sample was not scratched. Hardness of 3, the sample was not scratched. Hardness of 4, the sample was scratched. So that means whatever mineral is making up this particular rock has a hardness of less than 4. And this is consistent with calcite, because calcite on the Mohs scale has a hardness of 3. Okay, so everything seems to be suggesting that we have a rock made of calcite. So let's just come down here. So our option is going to be chemical or biologic. Well, as we've discussed, if we have a rock that's going to be made of calcium carbonate, calcite, and it's going to be biologic, we are going to be looking for pieces of fossil. And I think we can agree, if we come up here and look at this rock, and if we look at the close-up image, there's nothing there that would scream fossil. There's no obvious bit of shell, you know, there's no burrow, there's nothing in that rock that makes you think there's a fossil in there. So it's pretty fossil free. So that would suggest we're dealing with a chemical rock. Obviously, because it's a chemical rock, there's no grain size because the crystals are going to be very small, so skip that. Now we've just discussed how the mineral is going to be calcite, and so that brings us across here to limestone. All right, good. So now we've filled out our 4 options, so now we're going to ask the website how we've done. Now if you look down here at the bottom, it says grade identification. So I'm just going to bring the grade identification so it's right down at the bottom of the page, and I'm then going to hit grade identification, and here it goes. Congratulations, we got it right. So it's telling us that we succeeded in classifying our rock correctly. Now don't click OK. What we're going to do next is you're going to reach for your keyboard and you're going to hit the print screen button. Okay, and that's going to take a screen grab of your, essentially, of your screen right now. So what are we going to do with that? Well, the next thing to do is to open up a Word document. Now in your Word document, the first page is going to have your name on it. The second page is going to be named sample 1. So you're going to put your image that you just took with the print screen onto this. So you're going to do Control V, and there's the image. Now you can see in my case I have 2 screens running, so obviously the image was rather extensive. So what we're going to do now is we're going to trim down the image. So we're going to essentially hit it with we're going to select on it, left mouse button, and that's going to select the image. And then up here you will notice that format has appeared at the top of the page. So we're going to hit format. And then as we come across, we're going to look for crop. There's the crop option. So we're going to select crop. And you'll notice that these grey little spheres and squares along the edge of the image are going to turn into black lines. So what we're going to do is we're going to drag the black lines around until we've removed all the excess material which we don't want. And then once we've done that, we're going to hit crop again to close crop. There we go. And then we're going to make our image larger just by clicking and dragging. And there we go. So in this image, what I've got is it's saying congratulations, you got it right. I have your table of answers so I can see what you did. And I have a little bit of the image behind so I can see what rock you were looking at. And that's it. And then the next page, you're going to do sample number 2. And so on. And so you're going to produce a document with 13 pages. There's going to be 12 rock images, essentially which are going to look like these. Each image is going to have the congratulations box, a little bit of the rock image just peeking out from behind it, and your table of answers. And so once you've done that, you're going to save it as a Word document, and then you're going to put it into a Dropbox on the class D2L page. And that's it. So I hope you find that. I hope you find this video helpful. If you do have problems with this lab, don't panic. You can ask me about it during the weekly office hours, which will be at the times shown on the class syllabus. All right. Have a good day, guys.